The MapSuite Android Geometric Functions Learning Sample shows some of the most popular ways you can manipulate points, lines, and polygons. For this sample, press the Go button in the upper right corner to run the selected geometric function. The first geometric function is union. This combines multiple polygons into one. Next, let's look at difference. This compares two polygons and cuts the second polygon out of the first. Now let's look at buffer. Buffer adds a buffer to a point, line, or polygon. This buffer can have square or rounded corners. Uses of this function include alerting people within 200 feet of a road or parcel, or visualizing a non-compete zone within 10 miles of a business. You can see a rounded buffer has been added around this polygon. Now let's look at scale. This scales the polygon up or down by a percentage centered on the centroid of the polygon. All right, now let's look at rotation. This rotates the shape by a number of degrees. All right, next is center point. This gets the center point of a polygon. This sample also shows the center of the bounding box, which is the rectangle that fits around the polygon. So we can see there's the centroid and the center of the bounding box. Now let's look at the area calculation. This shows the area of the polygon, which could be in hectares or acres. Now let's look at simplify. This takes a complex polygon and reduces the number of sides so that the new polygon is an estimate of the original. Complex polygons can be processor intensive, so if you only require an estimate, simplify can increase your performance. You can see that this new polygon has many fewer sides than the complex polygon. Now let's look at get shortest line. This calculates the distance between two features. With complex polygons, it's not always apparent to the human eye what the shortest line is, and so we use this function. And it could also be used to find the shortest distance between points and lines, not just polygons. Now let's look at get length, or the length calculation. This shows the length of a line. And the length could be in feet, meters, or you could modify the function to show kilometers, miles, whatever you'd like. In our example, we have miles. Now we can see get line on a line. This creates a new line based upon a subset of the existing line. For example, you could use this if there was a chemical spill on a road and you need to shut down the road for 1,000 feet around it. You could create a buffer around the point of 1,000 feet. Then where the buffer intersects the road, you know that that's the location of where the roadblocks need to be. Use get line on a line to highlight the section of the road that is impassable. Let's look at clip. This uses a polygon to cut out other features. In this example, the blue polygon is the cookie cutter. Upon running, only the features that are within the polygon remain. Now you can modify this function to perform the inverse if you'd like and just keep the features that are outside of the polygon. Let's check out Convex Hull. This encapsulates all points or polygons inside a perimeter. In our example, there are 5 fires in a field. You could use Convex Hull to highlight the burn area. There's also a shape with rounded edges and concave portions. Convex Hull is used to surround the shape and finish with no concave sections. Now let's look at envelope bounding box. If you have an irregular polygon, you can use envelope bounding box to display the rectangle that surrounds it, also known as the bounding box. This could be used if you wanted to zoom into that feature to know the extent of the zoom level. And finally, let's look at snapping. If a vertex is within a certain radius of a line or point, you can use snapping to align them. For example, if you've traced a road based upon aerial imagery and you're using your human hand, you could then use snapping to line up the vertexes to the points. In our example, the left vertex is within the radius of the line. It will snap to it, but the right vertex is not within the radius and therefore will not snap. Okay, now let's look at the code. We're going to start with splash activity right here. And splash activity is, you can see right here, it has the attribute of being the main launcher, and that means that it will run when the program is opened. And this splash activity displays the splash screen where it has the upload progress bar. After checking for the sample data being loaded, it calls main activity, which is right here. And main activity includes list view and slider view. Slider view sets up the sliding menu that slides in from the left side when you select the layer style. And list view, if we go to the definition of that, we can see that this is a Xamarin class, and that's used to display the style list in the menu. And the style list is loaded based upon this geometric functions XML file here, which shows what the different what the list of geometric functions should be. Okay. Now in this main activity here at the bottom, there's a function sample list view item click, and that runs on an item click event, like selecting a new layer style. And you can see then the activity sample is set to the style that was tapped on the screen. Over here in the samples folder, we have a function for each of the geometric functions, and or I guess a class for each of the geometric functions. Here under advanced, there's a base sample, and this class is inherited by each of the geometric functions. In base sample, this title text sets the header at the top of the screen. It uses map view. Let's look at the definition of that. We can see that this is the ThinkGeo map suite map controller. Now let's look at one of the geometric function samples. You can see here that it inherits base sample, and then it has an initialize map function which sets up the map for display, and then execute, which runs when go is selected in the top right corner to execute the geometric function. Well, thank you very much for watching the Map Suite Android Edition Geometric Functions Learning Sample.